So let's pretend I'm a scientist that works with the periodic table every day, and I'm always writing electron configurations. And today I had to write it for sulfur. So sulfur is right here. Now I'm going to do the same electron configuration reading I've been doing. So 1s1, 1s2. I finished that block, so I write 1s2. 2s1, 2s2. Finish that block, I write 2s2. 2p1, 2p2, 2p3, 2p4, 2p5, 2p6. Finish that block, I write 2p6. And I keep going. 3s1, 3s2. Finish that block, 3s2. 3p1, 3p2, 3p3, 3p4. 3p4. So that took me a while, right? And we are only at the very tippity top of the periodic table, and I still had to write out all of these things. So what the noble gas configuration does is makes it way shorter to do that. So my noble gases are all of these ones. That's why helium, although it's an S block element and it should go here, helium is over here because it is considered a noble gas. Noble meaning they don't react with anything. You can hit them, punch them, you can call them names and they don't react. They're noble. They're very happy with how they are. So noble gas configuration, instead of going from left to right and then left to right and then left to right and getting at my element, I can skip all of these first steps and go down to my noble gas that is closest to the period above what I'm looking for. So if I'm looking for sulfur, the noble gas closest to the period above, the row above, is neon. So I can write the sulfur noble gas configuration by writing neon in brackets. Neon. That's how I write it. Neon. And then reading it from there. So 3s1, 3s2. 2p1, 2p2, 2p3, 2p4. And that's it. So this electron configuration and this noble gas configuration lead me to the same element. So I have my highest energy levels still the same for both. They are the same configuration, but this one is way easier, way shorter for scientists to do on the daily. Also, if you notice, the highest energy levels that I have represented here underlined, they have 4 electrons plus 2 electrons. So they have 6 electrons here, 4 electrons, 2 electrons. So they have 6 electrons here. So I have 6 electrons total in my highest energy level. How the periodic table is also very cool is that it arranged elements based on their number of valence electrons. So my first group, group 1, has 1 valence electron. Group 2 has 2 valence electrons. Group 3 has 3 valence electrons. Well, they're not technically called group 3, but group 3A, 4A, 5A. So, or 13 through 18. Okay? So this one has 3 valence electrons, 4 valence electrons, 5 valence electrons, 6 valence electrons, 7 valence electrons, and 8 valence electrons. Well, 2 for helium because it's supposed to be over here. But these ones have 8. Okay? So, if I look again at the total number of valence electrons that I got simply from looking at my electron configurations, both of them are 6. And I know that sulfur is on my group 6A, or group, 16. So I already know that it has 6. So this is just a way of double checking that I did it right. Also a way to easily find the number of valence electrons given the noble gas configuration.